Okay, hello everyone. So welcome to Introduction to Python. My name is Misha, and I'll be hosting a workshop today. So off the bat, this workshop is more intended for someone who's completely new, even to programming, and hopefully you'll be able to pick up some stuff. But even if you know Python, maybe you'll hopefully find something new. So my intention with this workshop is going to be to present a bit of reasoning why we're going to be covering Python. And then from there is going to be a bit more interactive. So I'll be going over some of the features Python has, and then hopefully give you a good intuition behind a lot of what you can do with it. So again, we'll hop over to the browser in a bit. So we're going to be using Replit for the main of the coding. So on the Discord, you'll find a link to it. And if you want to follow along, please hop on as well. So let's start off as to why we actually want to learn Python and why I like Python so much. First of all, there's so many great resources Python offers. There are many video tutorials and a lot of documentation for the Python language. It's very easy to find something and places to learn. Second of all, it's very quick and intuitive to write. A lot of Python seems like you can just talk it out. It feels a lot like English in a way. So being able to understand and a reason behind like what's going on, I find to be really easy. And third of all, there's a lot of existing code for Python. So many languages, they have tools, and then gives you, again, the tools, and then you can figure out what you want to do with it. Here, many people have built for many years different libraries and modules to give you with basic functionality of many things. So it's great in terms of having a lot of an existing code base, so you don't have to worry about as much. So at this point, let's jump into a browser. Again, I'm going to be using Replit, and then hopefully you can log on and follow along. You'll have to log in with an account, and then hopefully make a Python Replit. But again, yes, if you want to take notes, that's great as well. So I'm going to start off Python explaining what the shell is. So we see here two different areas. So this is the file. So this is like a file, and we can type lines of code and eventually run the file. Here, what the shell is, the Python shell, the idea is more you type something in and it gets evaluated immediately. So what the shell actually does is it reads one line or maybe a few lines in certain cases, and then it evaluates what you wrote, and then it prints it out. So to begin, let's start with some basic arithmetic. So we can type in, for example, 1 plus 2, and it'll spit out 3. So we can do other operations. So 1 minus 2, for example, and then multiplication, division, and then a special kind of division. So that's called floor division. And then 2 more operations. One is exponentiation. So 2 to exponent 4 is 16. And then a remainder. So 10, then you divide by 3, and then you will get a remainder 1. So let me quickly explain what these are. So we have, addition, subtraction, multiplication, and division. Those work very much as what you expect. Here, what floor division does. The idea is, for the most part, usually when we say 3 divided by 2, that would be 1/2 or 1.5. So what floor division does, it rounds down to the nearest integer. So if we go, for example, 7 divided by 3, that's 2.333. So, but if we go floor division, that becomes 2, because it truncates down. So we'll see some use cases for why we would want that later. So something you might notice at this point is here, a lot of these, or let me give an example first. So for example, 4 divided by 2 and 4 division 2. So we can see there's a slight difference in the results. So the first one, just normally dividing, that's going to give you a number with a decimal. Second one is just an integer. So the reason why it's printed differently is that these are actually different kinds of numbers. So in Python, we have 2 basic numbers. So one of them is the integers, so 1, 2, 3, and then negatives as well. And then we have what's called a floating point number. This is the ones with the decimals. So those are, again, the decimal numbers. So what we can do is also convert between them. Or, sorry, before we go on, we can check what the types are. For example, we can go 4 divided by 2. Indeed, that says it's a float. And then type normal one, that's an int. So we can also, as I mentioned briefly, go between them. So for example, we can int 1.3. So what that does is we can't really represent the decimal part in an integer, so it just truncates down, kind of like what the floor division would do. So in essence, that would be like 1.3 divided by 1, or if you would, that truncated down. So you divide by 1. So that's going from floats to ints. And then going other way, it's more exact. So just going, it just adds a decimal. So that just converts between the two a bit. So after that, let's go back onto, sorry. So now I'm going to introduce something called a variable. So sometimes we don't exactly want to like store constant values. So we have the up until now, so we've used here, we've just been putting in the number that we want. So here, what we can do is what's known as storing a variable. So we can give the, what we do is we give it a name. So we want to identify somehow what the variable is. So let's call it x, for example, and just put 1 in it. So from there, what this is saying, so we want to evaluate the right side and put that value on the left side. So for example, y equals 4 times 3 plus 1. So that would mean we evaluate this side here, and then we put that value in the y variable. So if we now look at what's actually in the y variable, that would be 13. So something I'm kind of hinting at here is that you can do multiple operations at the same time. So for example, I can go 1 plus 3 times 2 divided by 4, for example, and then minus 3. And something Python does, it also considers order of operations. So we know bedmass, that's brackets, exponents, division, multiplication, addition, subtraction. So here, it would evaluate the middle part first, and then do the addition of the 1 and subtraction of 3. So that would be 1.5 here, plus 1, minus 3, that's minus a half. Then again, with the brackets, we can also put in brackets in, and same with exponents. But so that what I want to also get at is the variables can be part of the expression. So y, for example, we can set y as x plus 3. So if we remember what x was up here, this was x equals 1. So we want to evaluate what x is. So this is essentially saying, what is x? We put in 1, and then 1 is 1 plus 3, x equals it's 4. So if we go back here, we can say again, y equals x plus 3, that should be 4, and indeed it is. So what we have is basically a way of naming certain values. So again, with the variables, so we can place certain x equals 1 or y equals x plus 3. And then something special we can do is, so often in math, we don't have a way of having the same variable on both sides. What I mean is, for example, 1 x equals x plus 1. This doesn't really make sense in math because this would mean that 0 equals 1. So there's no actual solution for x. Like x can't be any value. But here, this is a bit of a different way of looking at it. So x, what is x at the moment? So that's, we have x equals 1. So again, we put in x equals 1, so like substitute the value in place of the variable and evaluate this to 2. So if we do x equals x plus 1, then we go to x, as I talked about, x would be 2. So this is the essence of the arithmetic, like using numbers and having variables to be able to store the different values. So I want to now introduce going away from the shell. So up until this point, we've been using the shell, just evaluating the values directly. I want to move on to actually having a file. So if we do some of the similar stuff, so for example, x equals 4, x plus 2, x, y equals 3 minus x, and for example, we want to do x, how I just put in y. So now if we run this, so nothing shows up, but the reason why. So I talked about a bit before, like what the shell does. It reads the next line or so of what we wrote, then it evaluates it. So it does all the simplification, and then it prints it out. Here with these, it just tries to read it and then evaluate it. So it doesn't do any of the printing part. So what we have to do instead is print it out ourselves. So for example, here we want to so how we do that is using a command called print. So print here, and then we wrap what we want to print in brackets. And then it's similar here with y. So now if we run it, so x equals 4, we expect x plus 2 to be 6. Y is minus 1, then just print y. So let's see. Let's copy this to main. So what we have here is the main Python file runs, and it prints out, again, x plus 2, which is evaluates to 6, and then y, which evaluates to minus 1. So again, a big difference between what we were doing before. So here, again, we can do 4 minus 3, 2. It'll evaluate and print right away. So, and then here we have to explicitly print. So the next thing I want to talk a bit about. So we've been working a lot with just the pure numbers. So the two types, ints and floats. So I want to introduce a text sort of type called a string. So instead of using numbers, let's say we have a message equals a very stylistic first message is print or hello world. So this is a common convention whenever you start with a new language or a framework, you do hello world. So what a string is text inside of two quotes. So these two quotes, they can be as like here, double quotes or single quote, so message, or if we want to do three multiple lines, so line 1, line 2, line 3, and then these would all be strings in this case. So now if we run that, it'll print the 3 pieces of text that we put into variables. So this will be a start. So this is the start we're going to be using strings. So going on from that, we also, at this point, we haven't been doing much with, or all we've been doing is just hard coding a lot of the values. So we're writing exactly what the program wants to do. So we want a bit more ability to interact with the program. How we do that is using another command called input. So if we go, for example, name equals input, and then print hello, and then name. So what that's going to do is it's going to ask the user for input and then put the value from that into name, and then print out hello. So if we run that, so nothing shows up. It's waiting for us to do something. So, but I don't actually know what I need to write. Let's say I put in 45. It says, hello 45. Obviously that's not my name. So what we can do instead is give the input command a prompt to give the user. So for example, this is where strings come in. So inside we put in a string, what is your name? Then to make it prettier, we can put a space. But if we run that again, it asks you, what's your name? And I'll put in Misha, and it prints it out. And so that is at the the most basic way to interact with the user. Basically, we ask for some sort of input, and then they type it in, and we get a string. So now at the moment, if we go back, so we can look at what the type of name is. So if we run this again, it says it's a string. So what we get back is, again, the text type that we have, the string. So what if instead we want to have a number, then print out like that number squared? So let's ask, give me a number. And then your number squared is, and then And then here, we'll just type in the easy way. So squaring is just multiplying by itself twice. So let's see what happens there. So let's give it a number. Let's say 10. That should be 100. Well, so here we got an error. So what Python doesn't like is that it doesn't know how to multiply two strings together. So we saw that if I take the type of from the input, it will be a string. But as I said, Python doesn't know how to multiply two strings together. So what we need to do is somehow kind of how we converted between floats and ints, convert between strings and integers and floats. So what we can try to do here is convert that into an int. So kind of in the same way. So for example, if I typed the 10, that would be in a string. So we want to evaluate on the right-hand side of the equal sign, the variable n. So let's pretend that I typed in 10 again. That would evaluate to 10, and then the int would convert that into an integer. So let's try that now. So let's give me a number, 10, and it resulted in what we wanted. So n at that point was an integer, so it knew exactly how to multiply the two. So what we can also do, so here we did this conversion in two different lines. What we can do instead is wrap the int in this input. So kind of what I've been trying to get at is Python evaluates steps, like values step by step, kind of like how we do arithmetic. So I showed you the example, 1 plus 3 times 2 divided by 4 minus 3. I think that was the example. So how Python, again, would evaluate this, it would do in order of operations. So that would become a 6. This would become a 1.5. Then it would evaluate this, 2.5, and then negative 0.5 here. So this really is the essence of what Python's about. Evaluating stuff, or not just Python, just programming in general. Evaluating stuff step by step. So here, for example, we have the input. So it waits for the number, and that evaluates to the number 10. So we have 10 here, and this converts into the actual number. So we see here that Python, so like step by step, eventually gets to a simple single value, like 10 here. So something, before we move on, I want to quickly talk about a small part of Python, but that's actually very important in overall designing. So they're called comments. So what you can do is give notes to yourself or like future readers or people who, again, read your code later on, what you're trying to do here. So for example, if we go back to this part, so let's say, so how we specify a comment is using this hashtag symbol, and everything on the line after will be ignored by Python. So here we get a number from the user, for example. So that will be what that line does. And then here, print number squared. So something to note here is we put the comment symbol after the actual line. So only stuff after this comment hashtag will be ignored. So up until after this would not be part of what like Python tries to evaluate. So let's quickly copy that over to Scratchpad. Now, we started doing some logic with getting input from the user and then interacting, but we haven't really have any logic in the program. So we kind of just been doing it line by line. So first we get the input, then we print something out. We might add stuff together, then print something else out. So that doesn't really give too much depth into like what's possible. So I'm going to start with showing you another type to begin. But the lead up is basically we want to be able to control like which way we like how the program the control flow of the program. So now I'm gonna introduce a Boolean type. So what a Boolean is basically just a yes or no, true or false. So here, say A is true with a capital T, and then B is false. So these are the two primitive values. So basically the most basic values for Booleans. So there are two ways to usually combine two Booleans, or get a Boolean and then combine them. So the first basic way is using comparisons. So we often know, like, we have a good sense of, for example, like numbers and then how they relate to each other. So in Python, we also have operators to do that. So for example, we have 1, and we ask, is it smaller than 10? And then Python gives it to us that it's true. So 1 is indeed smaller than 10. How about 2 is bigger than 4? That's false. So we ask Python, check what this value is, like the 1, for example, then check what the 10 value is, and tell us if it's smaller or greater. So there are 6 comparison operators. So let's start with 2 equals 4. So what this double equals means is it checks if the 2 values are the same. Yeah, the reason why we don't have, so in math, we usually have a single equals to denote that 2 things are the same, but that's reserved at the moment for assignment. So we had the variable, so x equals 1, y equals x plus 2. So the single equals is reserved for that sort of stuff. Here, yeah, again, now the double equals is used for comparisons. So now we can also check if it's not equal. So I also want to show you quickly, we can also do all of these comparisons with strings. So let's say ABC not equal to DEF, for example. So the 2 don't have the same text, so they're not equal. But let's say we have ABC not equal ABC. They are the same text, so they would be equal. And the third one is the less than operator I showed above. fourth one is the greater than and greater than. And we can combine the equality and the two comparisons or inequalities to do it in a single check. So we can do less than or equal to, and then, for example, ABC. So this checks if ABC is less than itself or equal to. Well, it is equal to, so that would be true. How about, let's see, ABB is bigger than ABE. So that would be false. So an intuition as to how to compare two strings, basically, at least for letters for now, if if one letter comes after in the alphabet, then that would mean that would be come after. So for example, if we do A is less than B, that would be true because B comes after. So we would sort or consider A to be smaller. Now, these comparisons are actually very good by themselves, but we can also combine two Booleans together. So in main, let's do true for C, B equals false. So what we can do from here is combine them. Well, so we have, in English especially, have notions of combining two different statements. So for example, going to a store, for example, let's say we want to buy eggs if either they're on sale or we have none in the fridge. So there are two statements here. Like, are eggs on sale? And do we have eggs in the fridge? So those two are our Boolean questions or comparisons in that case. And then we will do it if either of them are true. So Python has 30 ways of combining them, or two that take two Boolean values and one that takes one. So that would be print A and B, print A or B, print not A. So it's and, or, and not. So and is basically both of the two statements have to be true, or means either of them have to be true, and not just inverts one of the values. So if we run this, so B, we see B is false, so and is false, or we see A is true, so we have at least one of them, and A is true, so not A is false. So using these, we can start building a bit more complex programs. So let's start let's start evaluating a bit more, like going more in depth as into looking at what the user gives. So let's say in one, that's we want a first number, and then give me a number, for example, and let's do get a second number. So now we have two numbers from the user. So let's do some checks, and then let's do some comparisons here. So let's the first one. If n1 is less than n2, then let's print out first is less than second. So here I introduced a very big keyword called if. So this means that we do this comparison. This should evaluate to some Boolean or some true free value. And from there, if that is true, then we run this code here. So something to note is the indentation. So here we have a few spaces to indent. And this signifies that everything under this like level of indentation is under the if block. So we can run, for example, x equals 2, print that, print here, some value, and then let's see, let's run that. So first, let's give 4 and 5, for example. So we see so 4, which is the first number, is indeed smaller than 5, the second number. And so that means we want to run this code here. So, and then after we see the two print statements there. So that's if it is true. But let's try running again and reverse the two numbers. So 5 and 4. So nothing happens otherwise. So, and then that's just a single if by itself. So there, you can expand the if a bit. So for example, if the if doesn't happen, like always if the if doesn't happen, then we can print here. So if n1 is less than n2, we go here. Otherwise, we print first is at least the second. So now if we run, for example, 5 and 4, the first is we see this else happening. So this is like the first building blocks of getting some logic in. So in between the if and else, we can have some extra statements. So if the first one fails, we go into a second case, and then into a third case, and then up until we hit an else. So we signify a second case using elif. So if n1 is equal to n2, for example, then print first and second are equal. So what's going to do, again, do this first check the first number is less than the second number. If that fails, it's going to do this one. And then if both fail, like it exhausts everything else, then it'll go into else block. So again, let's check the numbers. So 4, and then let's go 3. Didn't hit either of the first two cases. And then 4, 3, and 3, for example, the first two are equal. So it checks them from top to bottom in order. And then whichever the first one it hits, it'll go into that block. So this is the essence of if statements. So again, this concept of going into the first block is very important. So I didn't show this until up until yet. So if, for example, we try to in math, we have we can't really divide by 0. It doesn't really make sense, or it's undefined. So for example, if we just do 1 divided by 0, for example, it'll give us an error here. So a division by 0. So let's quickly write. So we have two numbers. Well, we want to print out what the quotient is. So what the result of the division is. So let's just print n1 divided by n2. So if we do 5 and 2, that's exactly what we'll expect, 2.5. So we just print out what we divide by. But let's say the user doesn't know what we're actually trying to do, or they want to be cheeky and give us a 0. So for example, 2 and 0. Our program errors because we tried to, again, try to divide by 0. So this is where the if statements are very good. So for example, we can specifically check, because we know what we're trying to do, we can divide or check what n2 is, so the divisor. So if n2 is 0, print divisor is 0, and then else print here. So now this is just being safe. So 2 and 0, we don't encounter the error anymore because we checked specifically for the error. Now, from here, something that we have been doing is going line by line and then just keep going down. So we've never actually, our code terminates pretty quickly. And so we go this first line, then the second line, then check the if, and then after we hit, check all the lines, we see there's nothing left, so the program finishes. So we don't actually we don't repeat any code. So sometimes we want to be able to run code multiple times or do something until some sort of condition. So this is where loops come in. So Python has two kinds of loops. The first one is kind of ties into conditions or like the if statements very well. That's the while loop. So for example, so that happens with the keyword while. So while, and then let's say n1 is bigger than 0, we want to print n1. So what it's going to do, this is the part that I'm saying, like I mentioned, that it reads pretty much like English. So while n1 is bigger than 0, like you do this code. So let's get rid of the n2 for now. So give me a number. Let's go 2. So you can see it's looping forever at this point. So it keeps on printing, and then it doesn't stop. So this is, nothing's happening with the n1 value. So we gave it 2, and it keeps going because, again, it never changes. So let's do a quick countdown timer, or a quick countdown. So again, let's keep the print n1, and then n equals n minus 1. So we can see here this, or n1, you decrease n1. So here, again, the intuition behind this is you take the previous value of n1 and just decrease it by 1. So let's run this now. So it's going to take a second to stop. Let's see. Okay, so let's just run it here for a second. Oh, it's good now. So give me a number. So let's give it 100, for example. So you can now see one by one, it prints out the values one by one, and it decreases each time. And then, as we expect, eventually hits 0, and we're done. So this is the while loop. So we can have a bit more complex conditions. So let's bring back n2. So and 1 is bigger than 0, 0, and 2 is bigger than 0. So let's try decreasing both at the same time. So let's print both out, n1 and 2 equals n2 minus 1. So this is the compound, like a compound statement that like from the Boolean operators we used before. So give me a number. So it would be 40, for example. This would be 30. And then it prints out the pairs until one of them becomes 0, in this case, n2. So that's the essential how while loops work. They keep going while some condition holds. And then there's a second one called a for loop. That one you specify, it's a lot easier to specify exactly how many times to loop over something. So here for, let's go I in range, and then let's start with 10. So let's start with a constant value. So this syntax here, for I in range, this signifies one way of doing a for loop. So this range, basically, well, let's print I out, and we'll see what range is. So these don't matter. So I starts at 1, then becomes, or 0, then becomes 1, then becomes 2, 3, and then up to 9. So I don't know about you, but like when I started learning Python, I found it's starting at 0 to be kind of unexpected. So like often when we start counting, we start at 1, but here it starts at 0, and then it ends at 9. So 1 less than the value that we specified, 10 here. So, but it did loop over 10 times. So if you count how many numbers there are, it is 10. But I'll show you why exactly it's from 0 to 1 minus the number we specify. And here, yeah, we can do something. We can specify a few more parameters for the for loop. So we can go 20, for example, 10 and 20 give 2 numbers. So what this is going to do is going to start at 10 and then end 1 before 20. So if we run this again. So it starts at 10, that's the first value, and it ends at 1 minus the second value. So this is great for if you want like a different range of numbers. And then there's another one. You can add another one. So a third one. So for example, we specify a 2. So this is how much we increment by every single time. So 10, then we go up by 2 to 12, then to 14, 16, 18, and then we don't do anything at 20 because that's not smaller than 20. And so these range you can configure a bit to do more, a bit more of what you want. So for example, we can also count down. So 10 from 20 to 10 going down by 1. So yeah, starting at 20 and then going by 1 down each time. And so this is at the moment the basic numerical sort of for loops that we're gonna that are easier to work with. I'll show you a bit more over a bit more in for loops a bit later, but now we're going to be looking at something like as a new concept. So we're going to be looking at a new type even. Up until now, when we've been looking at the values, all of them have been just a single value. So we have x equals 1, and then y equals 3.5, 3.4, S equals hello, B equals true. So these are really just a single value. So one piece of text, one number, one true or false. So now we want to look at collections of values. So multiple values at the same time. And so what Python has, one of the ways Python can represent this is using a list. So we can have a list of numbers. So for example, 1, 2, 3, 4. And we put the numbers or the items we want inside of square brackets. And so this would be a list. So similar to the other ones, we can print out the type of L. So yeah, we can see it's a list. So lists have a few operations we can do with them. First of all, we can get a certain item in a list. So let's get item 1. And how we do that is we put in the variable and then reference it with square brackets like this. So lists operate with a lot of the square brackets. So if we try it on L, so we want to try to get the first element. Now, we want to print that one out. So let's run that. But you can see it gives 2. So index 1 here that we specify is actually the second element in the list that we specified here. And so what's happening here? Similar to this is how range a bit relates to lists, and y starts at 0. The first element in a list is actually index 0. So if we go index 0, that will give you 1. And then now we can try to loop over all of them. But for I in range, for example, 4. So we know we have 4 elements in the list. Let's print li. So this variable, every single time it will change. So I it will evaluate to 1 first, 0, then 1, L2, L3. So let's print this out. So 1, 2, 3, 4. So what if we now go above 4? So what happens if we go to index 4, for example? So Python gives you, in this case, an error. It says index out of range. So for lists, we can't go beyond how many elements are in the list. How about, so the most safest way to go in a list is to go up until the length. And what we can do is we can get the length using the len function or command. So length L, then range L, for example, just to make it a bit easier to read. So we can get how many elements are actually in the list. So another neat trick in Python with lists specifically is we can have negative indices. So if we, for example, print L -1, so it's kind of unclear as to what that's going to give. So let's print it out. So it gave us 4 again. We can see here. This, and then if we go back and do -2, for example, it gives us 3, and then it'll give us 2 for -3, and -4 gives us 1. So negative indices, so if you give a negative number, it'll count backwards from the end to the start of the list. So that's a neat trick with lists in that case. But so I said recently that we have a different way of doing a for loops. So this is, you can just use the list by itself. So before we did for I in range 4, for example, but instead here, we can go and loop over the list itself. So for I in L and print I. So let's modify some of these values. So let's do 12, 21, 33, 4. And then at each point, I becomes the actual value in the list. So it starts at 12, then 21, 33, and 4. And this is just a slightly easier way to work with lists. And some other things you might want to do with lists. So we have L. So this is just defining a list by itself. We're not always going to know right off the bat what the lists are. So we can do L.append. So what this will do, it'll add on to the end of the list. So let's say we want to add on 10, for example, then print L. We can see 10 was added onto the end. Then we have similar operations for deleting and then modifying and removing. So let's look at how to actually modify an element. So this will just work in the same way as indexing, except we treat the element in the list as a variable. So like on assignment. So for example, L2, that will be now the 0. So L2, as we discussed, that's going to be the third element because it starts at 0. And we're going to set 30 and 33 here to 0. So if we print that out now, indeed, we modified that. And then there are a few ways to remove stuff from a list. So first one, the easiest one is pop. Figure just which index do you want to remove. So this works in the same way as like you can specify anything, any index that you can normally would to access. So for example, you can do 3. I'll remove the third element or the fourth element here. So 4, 4. So yeah, let's run that. So 4 is just gone. Or we can go from backwards. So -5, for example, that'll be the first one. So 12 is going to be gone. And so that's the first basic way. Another one is just to call remove here. So let's remove the 4. So what it's going to do is it's going to look for a value, an element in the list with value 4. So we know we're going to have one because we defined the fourth element as 4. So it's going to go through, and if it finds one, it's going to delete the element. So that's, in a nutshell, the ways you can interact and work with a list. So that's, again, lists, a breakdown. So let's move on a bit into bundling a bit of what we've been doing into more compact and reusable snippets. So we've used a few functions at this point. So these commands that we've been running. So we've been using print, we've been using input, and just now we saw like lists, append, and pop. So we've seen how to use some of these commands, but now we want to actually define them. So how we do that is we use a def keyword and we give it a name. So let's say greeting, for example. And then what greeting will do is just print hello. So let's look at quickly the format here of actually making this function. So we have, again, the def keyword, then we have the name of the function. So in this case, greeting. Then we have two parentheses. So in print, for example, we specified exactly like what we want to print. And then, yeah, it displayed that. So eventually we can give it a few parameters and like have it tweak the behavior a bit. But for now, let's just have it blank. And then kind of like with the if and the loop, we have the colon to signify like this is the start of the block. So now if we run this, we notice nothing happens. The idea behind this, print, when we ran print, you can see here even, it's in, there are, we write the actual print function, and then we put parentheses around these. So this is called calling the function. So we define a function, and then we need to actually use it. So below here, let's actually use this function. So greeting. And we put the brackets, and then when we run it, now it actually does it. So what we can do, for example, we can do it multiple times. So this is the benefit of defining a function. So a lot of times we want to like reuse a lot of the same logic and code in multiple different parts. And this is a great way to bundle that up and then, again, reuse it. So this is the first step. So just defining a function. So this is kind of analogous to the prints we had before. Basically, we call print and it does something for us. So that's not exactly what input does. So input does something like it maybe outputs a prompt and then gives something back. And so maybe we also want something kind of like input. So how we do that is inside of the function. So let's say, let's write an adder function. This is kind of redundant, but it's a good example. And then we want two arguments. So as I mentioned, print, for example, has, like you can give it what you want it to print. So here we give it, we give add two numbers. So add A and B. And then we want the result back from like what the actual addition is. So we use something called the return keyword and then give it an expression. So A plus B. So the idea here is that, again, you give it two numbers and then it adds them together. And then let's print add 1 and 2, for example. So the add function should return 3 in this case. Or if we have like 5, that'll be 7. Yeah, that's pretty much, that's pretty self-explanatory. That how add actually works. Now, let's say we want to do the logic before what we had before. So if with the quotient, so we had the idea that if the divisor is 0, then we give it back. Oh, the divisor is 0, and then otherwise we give the actual quotient back. So if b that's 0, then return, and let's return a string this time. Divisor is 0, and otherwise let's return a divided by b. And let's call that div for now. Div. So right now that should be 2.5. And then if we do that, it will be the other one. So that's the if statement. So I didn't expose something I want you to notice here is this use of a return, and then it immediately exits the function. So here you can see, like in the if statement, we called return, but it never actually divided. So we never actually got here. So this idea is the return automatically, like immediately gets you out of the function. So nothing else runs. It's yeah, it's useful in these sorts of error cases. So before going on to the last few things, I want to start getting into a nice, concrete, and a bit of a bigger example with all of these different, like having different functions and using them. So something I wanted to do is have us generate a list of prime numbers. So just to remind you what a prime number is, if you forget, it's basically a number that only that has exactly two divisors, 1 and itself. So for example, 2 is a prime number. It's only divisible by 2 and 1, 3, 5, 7. So we want to be able to ask the user how many do we want, and generate and give them a list of that many prime numbers, like from smallest to largest. So before that, let's go back a little bit, and so a big aspect of prime numbers is this divisibility. So only 2 factors. So only 2 things divide it. And so in Python, this divisibility is checked with the modulo operator. So that's the remainder one. So a while back I showed you, for example, 10 modulo 3. Modulo 3. So the reason why it returns 1, so 10, that's equal to 3 times 3 plus 1. So this becomes the 9, and then you add the 1. And then there's no way for 3 to divide this 1. So that's the remainder. So the way we check divisibility in this case then is to use this operator. So let's look at using this operator with different multiples. So let's look at all the multiples of 7. So 7 modulo 7, 14 modulo 7, 21 modulo 7, and 28 modulo 7. I think you get the pattern. It's always going to be 0. So 7, 14, 21, 28, they're all multiples of 7. And then all of them have 0 as a remainder. That's basically the definition of if something is divisible. So let's write a function for that. So define is divisible. And then we want 2 numbers, so A and B. And then we want to give back if this, so remainder equals A modulo B, and then return remainder equals 0. We can put this into a single statement. We can just do return A modulo B equals 0, but this is a bit more, explains what we're trying to do. So is divisible. Now, going back to something I mentioned before, comments, let's make sure people understand what we're actually trying to do here. So returns true if A is divisible by B. So just to make sure, again, people understand. And then now let's get into checking if something is prime. So again, we want to write an is prime number or is prime function. And in this case, we wanted to check one number is prime. And then returns true if n is prime. So now the question is, how do we do that? So if something, let's do some logic and like thinking about what actually, when can n actually be divisible by something. So we only care about if it's divisible by something that's at least 1. So that's already arranged. So we only need to check everything above 1. And then let's think, can anything above n itself divide n? So if something is already bigger, then dividing it just doesn't, you can't be a divisor if you're something bigger than a dividend. So we can just go up until n itself, or 1 less than n, and then that'll be our algorithm to calculate is prime. So for I, in range, go from 1 to n. And then if n modulo I, or even better, we already wrote a function for that, is divisible. And by I, then return false. And otherwise, after all the for loop, return true. So if we've exhausted all of the numbers between 1 and n, then that will just mean it's not prime. So let's try with an actual prime number. So let's run this quickly to define the functions. Is prime 2, for example? Well, 2 should be true, but it isn't at the moment. So it's returning false for us. So why is that? So I think the logic here is a bit wrong, because here we try to divide by 1. But if we divide anything by 1, 5 modulo 1, it's always going to be 0, because everything is divisible by 1. So we don't actually want to go from 1 to n, we're going to go from 2 to n. So let's run that again to define the functions. Let's try, for example, 7. So 7 is a prime. 9, that's not a prime. This is for 19, for example. That is a prime. So that works there. But now let's try 2. 2. So that seems to be working fine. So going from 2 to n, and then checking if divisibility. So now let's produce this whole list. So we defined the 2 functions. So we have all of these capabilities. So let's ask the user how many equals int input, how many primes. And then we start off with just an empty list. We don't know how many or any of the primes yet. And then for I in range, how many? Again, this will loop how many times. And then, let's add an actual number to, or let's do it in a bit of a different way. So the for loop, we want to do how many times, but we don't know how many actual numbers we want to check. So what we do know, so what condition do we actually know? We want the length of L. So this is let's rename this slightly to primes. So we want primes to have 10 numbers in them. So while length of the primes, so primes is less than how many? Let's say, and then we start off with 2. We know that's a prime, so we know 1's not a prime, so we don't care about that one. Let's say if is prime n, then we add it to, or not L anymore, primes n, and then each time let's just n equals n plus 1. And after this goes, let's just print out all of our primes. So we'll try running this. Let's say we want 10 primes. So 2, 3, 5, 7, 11, 13, 17. That seems to be the first 10 primes. So we've done like the first part, but we've designed the functions to actually calculate it. Let's move it so it actually let's use this to demonstrate the next few ideas that I wanted to show. So, as I mentioned, like at the start, Python has a lot of existing libraries that you can use. So this is from math libraries or graphics libraries and like game engines. So you can use a lot of these existing to quickly speed up your development. So let's learn how to actually use those. And so let's quickly move this into a new file quickly. Let's call it primes.py for now. And let's look at how to get other people's code. So this is done using something called importing. So there are 3 basic formats of doing so. So we can do import, and we need to know what actual package or module we have. So I'm just gonna give one example. So math. And so from here, we can use parts of the math library using math dot and then the part. So you probably won't know like what all the parts are right away, but you can read up on it. Like there's going to be documentation. I'm going to give an example with square root sqrt and give 25, for example. So import math, and it calculates the square root for you. So you don't need to give it a perfect square. You can give it like 123. That will calculate 11.09. So you don't really care how the square root function, in this case, is implemented. The point is, other people wrote it, they know it works, and then you can use it. So you can also, in a similar way, use like pi, for example. It has a bunch of, or not too many, but enough decimals of pi. And then there are a few more formats to look at. So there's just import math by itself. You can do import math as, say, standard. So std math. So your standard library, and then in the same way, you can just do standard math .py. Yeah, works the same way. So the idea here is to give a different name to the same thing. So for example, if you have a long name and you want shortening down, or you have multiple of the same name, you can always just give it a slightly different name. And I can basically the idea is to rename something in a different way. And the final format is from math, import, and then give it what you want to import. So for example, the square root pi. And in this case, we don't even have to use like the math.pi. We can just use square root pi right away. So what's the square root of pi? 1.77 approximately. So this is how you use outside code in your own projects. So what we can also do is import our own stuff. So if we go back to and get our primes, so let's take this out and keep this is divisible and is prime in here. So how many? And then now here you might notice, let's try running this. So let's give it 5 prime, ask for 5 primes. Name is prime is not defined. So it doesn't actually know what is prime is at the moment. The reason why, it's not actually like we're not defining it anywhere. It doesn't know what this function is. So what we need to do is now import our own code. So import primes, or let's do the nicer one from primes import is prime. So how I found this primes, why I'm calling it primes, is because it's called primes.py. So you just take the first part and use that. So I'm gonna show you something else that's small with importing. So let's make a folder here. So folder, and put primes.py inside. So now we need to somehow navigate into the folder. And how we do that is just using from folder dot. So every folder down you go, you add the folder and a dot. So that could be like folder 1 dot folder 2 dot, and then however many you want to go down, and then primes. So now if we run this, this should work in the same way as before. So it was 5 primes. Now, so that's basically the whole idea behind importing modules and then getting your own stuff. But so something to quickly show you. So we have this scratchpad pie. Let's try importing this scratchpad. So what we have in there at the moment is give me a number, and it'll print the number squared. So let's try importing that. Import scratchpad. And now let's run that. So now you can see it asks you to give in a number. So what's happening here? Like in this file, we don't have any give me a number and whatever else does. So if it's 9, it gives it squared. So something to keep in mind, whenever you import something, it'll run the whole file. So it's running n equals give me a number, or input give me a number, your number squared is this. So this is why we're seeing give me a number and then printing out the square. But yeah, that we don't care about the scratchpad at the moment. So a final topic I want to talk about is interacting with files. So let's make a quick file with some text. So text.txt, for example. And then let's just say hello from a file. And then you can make a new line, doesn't really matter. But yeah, we'll just make a quick file. And then now we want to not only interact with the user, like the display, we're also going to look into reading and writing from files. So for now, I'm going to put this in prime calc.py. Doesn't matter the name. I'll copy it back in a moment. So how you open a file is using the open keyword. So f equals open and the file name. So in this case, that was text.txt. So open is a function, and it will return, give you a file that you can work with and read. So I'll just print f.read. Oh, let's stop that. And then, nice, hello from a file. So it found this file, it read it out, and then here we are. So this is, again, how we read from a file. So we can add some more lines. Let's say line 2, line 3. So some other ways of reading a file. So we have f.read lines, and this will return a list of the lists that we saw, lines equal this, and for L in lines, print L. And then this will do the same idea. So we see all the 3 lines printed. And then, but we can, instead of needing to do the read lines and then doing it, so Python has a small shortcut. We can just do 4 lines in F, print L, for L and L, F. This is just a small shortcut, same thing. So yeah, this is, in essence, just how a simple way to read from files, not too complicated. Cool. Now the cool part is to writing to files. So we're going to be writing to a new file. So out.text, for example. And how we specify that is giving it a second argument. So this is the second one is going to be what kind of interaction we're going to have. So by default, this is going to be just an R. This is just read the file. But we can also do write a file. So this is going to overwrite whatever is inside, and then create a new one. Or we can do append. So it's going to add on to the end of the file. But for now, we're just going to overwrite what's happening. And then let's just f.write. And it's not like simple, my output. Cool. So now we see a new file popped up. And if we look at it, so nothing showed up. So something quirky with files is that, and so the reason why this didn't happen was we didn't actually commit to writing to a file. So this is the f.write kind of just queues up. It's like, oh, here, this is what we're going to write whenever we actually do so. And then whenever you give the command to do so, that's going to actually write to the file. So just off the bat, if you need to write immediately, the way to do that is just f.flush. That'll flush the text through. Now we see that output. But something I haven't talked about yet, just because because it hasn't mattered yet, is closing the file. So good practice is if you open a file, you should close it later. So the reasons why behind this is some operating systems, I'm pretty sure Windows does this, it locks the file so no one else can access the file. So if you start reading it and then no one else can open it, and then if you never close it, then it's kind of locked there. So what we do with closing the file is, you might have expected this, f.close. Just call close. And then you'll notice here, let's just delete this quickly. And then if we do the same thing, my output shows up. So we didn't have to flush because closing automatically flushes. So, but it's much more cleaner to actually close the file once we're done. So now we're ready to finalize our program. So let's get back our prime calc. Now, instead of just printing, we want to output the primes line by line into a file. So let's loop over all the primes for p in primes. And we want the output here in a moment. So let's open the file, equals open, and then primes.txt. We want to overwrite the whole thing, and then the f.write, and then p, and then let's take a look here, and then f.close at the end. Let's see what happens here. So 10 primes. Oh, so we got an error. So write wants a string. So similar to converting from strings to ints, we can convert from an int to a string. So using str here, so that would convert there. So now if we run that, so 10 primes. So now we have the primes.txt. Let's take a look. Yeah, in a moment. Yeah, sorry. So so you can see here that all the primes are kind of jumbled up. So if we go back, so what's happening is the files actually have a special character to designate new lines. So usually when we hit enter, it just pops up a new line. But here we need a special character at the end. So f.write, let's just write it after. It's called \n. So this is the new line ASCII character. And then let's look at it now. Let's go 100 primes this time. And look at this, a nice prime for each line. So this is basically, this is basically what we wanted to get at the end. So there's only one small improvement that I want to make. So it's often tedious to need to close the file at the end, and then there may also be issues. For example, if I up here, I'll just go up here. F equals open my file and write it, and then print 1 divided by 0, and then f.close. So it looks like we're going to be closing the file, but the problem is here, at the error, it stops. So we opened the file, but we never actually got here because this line here errored. So this just has all the same problems as just not closing the file in the first place. So a special way of the format of working with files is using the with keyword. So with, and you specify the actual object. So file as f. Yeah. So the good thing here with open primes, so this wraps all of the closing and all the error checking and all that into like a default behavior. So we don't actually now have to worry about closing it, and we don't care about errors, and we can just do this. Well, yeah, this is all we need to write. So let's run this. Let's make 1,000 primes. Now it slowed down a bit. So Obviously, our way of calculating all the primes isn't the best, but yeah, we see all of these primes. So yeah, this is a great place to stop, and a great, an easy, like a nice product for demonstrating like all the different parts that I talked about. Now, I'm gonna go back, and I want to give you hopefully a few takeaways from this workshop. It ran much longer than I expected, so but here are a few things I want to for you to take away. First of all, the easiest way to remember all of this is to actually practice. So JAMHacks is a great way to actually try to use all of these different tools like for loops and functions and importing modules. So actually getting your hands dirty with using all of this is, I think, the best way to cement your knowledge for Python. But even more importantly, it's okay if you don't remember all of it. I saw people writing down notes and trying to copy everything down, but it's okay if you don't remember. The main point here is the ideas, and like, here's something I know Python can do. Let's look up how to do it, like how to write that down. So actually, like, the biggest point is, something exists, and let's find out how to use it. And then finally, I think the biggest, and a very important part is to actually be curious and then look for new things to learn, especially in Python, like new modules, like importing how to use math, or you can try to check out like a different, like some other one. And then don't be frustrated if you don't get it right away. The fact is, learning is hard, especially with something that you're brand new to, or something you just don't know about yet. Like, it's okay to be lost, completely lost with something, but the main point is to be patient, to stick to it, and then actually keep going and like keep trying at it. So, and hopefully you take some of these things away. It doesn't matter that it's hard now, but hopefully with practice you'll get better. So anyway, thank you for attending. It's been a long while. So I just want to mention again, I saw people taking notes. I have good reference documents on the GitHub. I linked it in the Discord under resources. So that gives you a few different examples and a few extra things, so a bit more advanced ideas, and like some links to articles and resources where you can look stuff up. So yeah, check that out if you're curious, and then especially if you don't remember something, it's probably in there if I mentioned it. So again, thank you for attending.